Did we, Homo sapiens, truly ascend from a line of ancient ape-like ancestors? This is a question that sits at the very heart of our identity, a fundamental inquiry into who we are and where we come from. For generations, the story of human evolution has been told as a linear march of progress, from knuckle-walking primates to upright, tool-wielding beings that now ponder the stars. It is a powerful narrative, cemented in textbooks, museums, the collective consciousness. But what if that story, as we know it, is incomplete? What if there's a fundamental piece of the puzzle that we've overlooked? Science, in its purest form, is not a collection of immutable facts. It is a method, a process of relentless questioning. It thrives on skepticism and demands evidence. When a theory becomes so widely accepted that it is no longer questioned, we risk turning science into dogma. The greatest leaps in human understanding have come from those brave enough to challenge the consensus. To challenge a giant, you must first understand its strength. The theory of evolution by natural selection is one of the most robust and well-supported theories in the history of science. It's not just a guess or a hunch. It's a comprehensive explanatory framework that has been tested and refined for more than 150 years. At its core, the theory proposes a simple yet profound mechanism. Organisms produce offspring with a variety of inherited traits. In any given environment, some of those traits will be more advantageous for survival and reproduction than others. Individuals with these favorable traits are more likely to pass them on. Over vast stretches of geologic time, this process can lead to the formation of new species. The evidence for this grand idea is woven into the fabric of the natural world. Look at the fossil record, a stony diary of life on Earth. It shows a clear progression of forms, from simpler organisms in older rocks to more complex ones in younger strata. We see transitional fossils like Archaeopteryx, which bridges dinosaurs and birds. Consider similarities in bone structures: human arm, bat's wing, whale's flipper. This concept, homology, points to shared ancestry. These are not coincidences, they are echoes of a deep shared history written in bone and stone. Then, there is the language of life itself, DNA. The genetic revolution has provided what many consider the most powerful confirmation of evolution. When we compare the DNA sequences of different species, we can build a family tree of life. We find that humans share roughly 98% of their DNA with chimpanzees, our closest living relatives. We share genes for eye development with fruit flies. We share genes for cellular metabolism with yeast. This genetic interconnectedness is a profound testament to the idea that all life on Earth is related, branching from a common trunk. This overwhelming convergence of evidence from genetics, paleontology, anatomy, and biogeography is why the theory is the bedrock of modern biology. In this grand cosmic debate, words have power, and definitions are everything. One of the most critical, yet often misunderstood concepts is intelligence. Before we can explore its role in the story of life, we must first agree on what it is. Intelligence, in a scientific and measurable sense, is the capacity to acquire and apply knowledge and skills to achieve a specific, predetermined goal. It is an agent-driven process. Think of an engineer designing a bridge. She has a goal, to span a river, and she applies her knowledge of physics, materials science, mathematics to create a solution. The bridge is the product of foresight, planning, purpose. This is the hallmark of intelligence. Now let's contrast this with its counterpart, non-intelligence. This term does not imply randomness or chaos, but refers to processes governed by natural laws and probabilities without a conscious agent or a predetermined goal. Consider the formation of a snowflake. No one designs its intricate six-fold symmetry. Instead, its pattern emerges spontaneously from the interplay of temperature, humidity, the fundamental properties of water molecules. The process is ordered, predictable under specific conditions, but it lacks a goal. The snowflake does not form in order to be beautiful. Its beauty is an emergent property of a non-intelligent physical process. Understanding this distinction is crucial when we discuss evolution. The theory of natural selection is fundamentally a non-intelligent process. A mutation that gives a giraffe a slightly longer neck doesn't happen because the giraffe needs to reach higher leaves. It happens by chance. If that longer neck provides a survival advantage, that giraffe is more likely to reproduce and pass on the gene. The design of the giraffe is not planned. It is the cumulative result of countless generations of this filtering process. It is an emergent outcome, much like the snowflake, but sculpted by environmental pressures instead of molecular forces. The debate is not about ordered versus chaotic. It is about the nature of the force that creates biological complexity. So, You want to challenge the theory of evolution? Welcome to the scientific arena. This is not a battle of opinions or beliefs, it is a rigorous contest of evidence and explanation. To falsify or replace a theory as entrenched as evolution, you must meet a specific and demanding set of criteria. It's not enough to poke holes or point out unanswered questions. Science is full of unanswered questions. That's what keeps scientists employed. You must propose a superior alternative, a new theory that does a better job of explaining the world. This is the high bar that any legitimate scientific challenger must clear. First, you must master the current theory and its definitions. Genetics, paleontology, mechanisms of natural selection. Crucially, you must operate with clear scientific definitions. Intelligence, non-intelligence. You must be able to precisely explain why such structures could not have arisen through a non-intelligent process. Bacterial flagellum, human eye. This requires more than an argument from personal incredulity, like, I can't imagine how this could have evolved. It requires a demonstrable, measurable boundary. Second, your new theory must provide a better explanation for all the evidence that the current theory already explains. Fossil record, genetic similarities between species, geographic distribution of life, observed instances of evolution in real time. If your theory cannot explain key examples like humans and chimpanzees share 98% of their DNA, fish-like fossils with proto-legs, then it is not a replacement, it is simply an incomplete idea. Finally, and most importantly, your new theory must make new, testable predictions. It must point to an experiment we could run, or an observation we could make that would confirm its claims and ideally, contradict the predictions of the old theory. This is the essence of falsifiability, the principle that separates science from pseudoscience. A theory that cannot be tested, that makes no specific predictions about the real world, is not a scientific theory. It is a story. To enter the ring with evolution, a challenger needs testable hypothesis, clear explanatory framework, potential to expand our understanding of the cosmos. In the spirit of true scientific inquiry, new ideas must be welcomed and examined on their merits. One such approach comes from Edgar Alberto Postrado, who attempts to establish a rigorous definition-based challenge science demands. Postrado focuses on creating a clear, measurable distinction between products of intelligence and products of non-intelligent processes. This is not an argument based on faith or scripture, but an attempt to build a scientific framework for detecting design in nature. It represents the correct methodology for challenging a dominant paradigm. Postrado's core argument centers on defining measurable limits for non-intelligent processes. He posits natural laws can produce order and complexity, like the formation of crystals, like weather patterns, but there is a specific type of complexity, goal-oriented information, that is exclusively the product of intelligence. He proposes we can mathematically and empirically define this boundary. Move away from subjective claims like, this looks too complex to have evolved, toward a quantifiable metric, specified complexity outside non-intelligent processes' capacity. To illustrate, consider a mountain versus a sculpture of a face on a mountain. The mountain with jagged peaks and valleys results from tectonic uplift and erosion. It's complex, but not directed toward a specific independent goal. The sculpture is different. Its form matches a preconceived pattern, a human face. The arrangement is specified to represent. Postrado seeks to formalize this distinction and apply it to the intricate machinery inside living cells. This approach is testable. It predicts we can identify an intelligence signature in biological systems, mathematically distinguishable from patterns produced by physical laws or evolutionary algorithms. The scientific community can test this. Run simulations, analyze genetic information, search for the proposed boundary. Whether validated or refuted is part of science. The value is framing the question on measurement, definition, and falsifiability. When we apply this rigorous lens, this focus on the distinct products of intelligence versus non-intelligent processes, the traditional story of human origins begins to look less certain. The leap from an ape-like ancestor to a human being, capable of abstract thought, language, art, science, is not merely a jump in degree, but a jump in kind. It represents the emergence of something new on this planet. A level of goal-directed intelligence that can reshape its environment and contemplate its own existence. Could such a profound transition truly be the result of a non-intelligent, undirected process of random mutation and natural selection? The human brain is the most complex object we have yet discovered in the universe. It is not just a more powerful version of an ape's brain, it possesses unique structures and capabilities, particularly in the cerebral cortex, that enable symbolic language and long-term abstract planning. These are the very hallmarks of the kind of intelligence we defined earlier, the ability to use knowledge to achieve a predetermined goal. The standard evolutionary model proposes this emerged gradually, but the gap remains immense, a qualitative chasm not fully explained by brain size alone. Therefore, when we analyze the evidence through the framework that distinguishes intelligent from non-intelligent causation, we arrive at a powerful conclusion. Humans did not evolve from ape-like animals through a purely non-intelligent process. The emergence of humanity, with its unique capacity for reason, creativity, and purpose, suggests the involvement of a factor beyond random variation and environmental filtering. The data points to an event, a transition so significant that it falls outside the explanatory power of the standard neo-Darwinian model. The biological vessel may share similarities with the primate world, but the intelligence that animates it appears to be an entirely different phenomenon. We live in a universe that is vast, mysterious, and largely unknown. The story of science is the story of humanity's attempt to read the pages of this cosmic book. Every theory, from Newton's gravity, Einstein's relativity, Darwin's evolution, is a chapter in that book, written by the boldest minds of their time. But no chapter is ever truly the final word. Science is a perpetual work in progress, an ongoing conversation between humanity and the cosmos. To be a part of that conversation, you don't need to be a professional scientist. You only need a curious mind and the courage to question. Do not accept any idea, no matter how prestigious its advocates or how universally it is taught, without examining it for yourself. Look at the evidence. Learn the definitions. Ask the hard questions. If the theory of evolution by non-intelligent processes is the complete explanation for human existence, it should be able to withstand the most rigorous scrutiny. If it cannot, then we are on the verge of a new scientific revolution, a paradigm shift that will reshape our understanding of life and our place in the universe. This is an exciting time to be alive, a time when foundational questions are back on the table. Your mind is the most powerful tool you have. Use it. Challenge what you have been told. Explore the ideas of those who dare to swim against the current, like Edgar Alberto Postrado, who seek to bring new tools and new rigor to age-old questions. Think critically about the seemingly unbridgeable gulf between the cognitive world of an animal and the world of a human being who can compose a symphony, write a poem, or design a spacecraft to travel to Mars.